absorptivities for X and for Y. Okay, so then again, whatever that is fine. But again, we're just going to use X and Y, right? And then giving you a table. I have very similar, just like this on the exam as well. Okay, so then I give you a certain wavelength, to say at 406. Okay, at that wavelength, you have the epsilon for X and you have the epsilon for Y. As I said, that still properly belongs temperature at that wavelength. Okay, so then that's just for that. And of course, I'll give you those information. And then you also, again, you probably, this is something like this, right? You did a measurement and then you just say you have something like that. Okay, so then you have at this wavelength, so this is 406 nanometer and this is 457. Okay, so that's what you measure and you gather the information. And then now you're going to use this information to figure out what's the concentration you have for X in that mixture, right? That's the story. Okay, so and then at a different wavelength, you have the epsilon. Again, that's just the reference information we're supposed to know, because we know what's that X and Y are. So we'll be able to find the information about their epsilon, right? So that molar absorptivity information. Okay, so at that particular wavelength. Okay, so then this is the background info you're supposed to know. And now let's see what the question is asking us. It's asking us a mixture of X and Y, and it's using 1 centimeter cell. Then if you go, oh, 1 centimeter cell, that's basically telling me the B, right? Remember, A equals to epsilon times B times C. That B information is 1 centimeter. Numerically, if it's 1, calculation-wise, that's easy, because you don't even need to plug it in or not. Numerically, they don't change the result. But this is what, the 5th time I'm mentioning this. Okay, on the exam, if I give you 0.1, can you just ignore it? Can you just not plug it in? Can we? Can we, if it's 0.1 or if it's 10, can you just ignore it, now plugging in the B value? No, that's going to change your final result. Okay, so make sure you plug it in if it's not a 1. Okay, so numerically it changed the values. Okay, so now I hope everyone is clear about that. Okay, so that's what that, and then you have absorbance A prime will be 0.722 at 406 nanometer, and then the A prime 2 primes will be 0.641 at 457 nanometer. And you're looking for the concentration of X and Y in this mixture. So then you're going to plug in your information values into these 2 equations. Okay, so now let's see how I'm going to plug information. Okay, so again, you go so many numbers. What I'm supposed to use, what I'm not supposed to use, right? Let's be clear about what that each symbol represents, and you for sure you know what to use. Okay, so now look at this. Clearly, we're dealing with at 2 different wavelengths. Okay, so at 406 nanometer, you're supposed to use this equation, right? Okay, so then I'm going to use that. Okay, so that's the equation I'm going to use. Let's plug in the values. Let's see, do you know which values we're supposed to plug in at this moment? Okay, at this moment, if I say A prime, I'm going to actually give it its subscript, right? So 406, A prime, when that's at 406, what's the epsilon prime for the X? What's that value should be? Look into the table. For X, what's that value? Supposed to be 720. I have the similar question on the exam, so please practice, so then you already get this done, right? You don't have to use more time later. Okay, so that's 720. B is supposed to be 1 centimeter. In this question, you don't have to really plug it in because it doesn't change the calculations. I'm just going to ignore it. Okay, so that's why I'm taking that out. And the X concentration, that's something we're looking for, right? We don't know, we're looking for that. So then that's for that part. Okay, and then epsilon for Y at 406, what that value is supposed to be? 212, right? So 212 times the concentration of Y. So that's for that. Okay, so did you really use this 406 nanometer? Did you need that for a particular calculation? You go, no, what about this then? What about the absorbance at 406 nanometer? What's that value supposed to be? Now I'm gonna plug that in. Okay, what's that value supposed to be as a detailed number? What is it gonna be from the question itself? Right? It should be what? 0.722. Right? So that's from the question. Okay, so now I'm gonna swap it out. Okay, so this will be 0.722. Okay, so then that's for that information. Okay, so now if we understand how to set this up, what about the second one what about at 457 nanometer? Can we set this up by on your own? I believe so, right? That'll be 0.641 equals to 479 concentration of X plus. I hope you know why I'm doing this. Okay, so if you're following, you should for sure. Okay, so now you have 2 equations, right? So I'm gonna bring my equations here. So now I have 2 equations. From this point, really just math, right? So you have 2 equations. You have 2 unknowns. We're supposed to solve both. So then I believe we know what to do, right? Okay, so I'm gonna put it in the order. So this is my second equation. Okay, so I'm gonna give this equation as equation 1, this as equation 2. So what's the way to solve for this? I'm gonna rearrange equation 1, right? Rearrange equation 1. Then I'm gonna use everything to express this X. Reorganize this equation, and I can get to 0.722 minus 212 concentration of Y divided by 720. Okay, so I'll say this equation is equation 3. Okay, so I'm gonna plug equation 3 into equation 2. Okay, so basically I'm gonna replace that X with my whole expression right over there. Okay, so when I do that, I'll just only have Y, right, in my calculation, so then I'll be able to solve for it. Okay, so I'm gonna plug it in. So here's what I did. Okay, so if you look at it at 0.61, now 479, I plug the whole thing in, right? So it's 720, that's 0.722 minus 212 times concentration of Y plus 274 concentration of Y. Okay, so then from this point, requires careful calculation in the sense of you have to do the calculation, make sure you have Y on one side and all the numbers on the other side. Okay, so this requires you please practice and you see how this works. I'm just gonna jump to the step. I come to 132.02 having times concentration Y will equals to 0.161. They'll be able to calculate the concentration of Y in this mixture. This comes as 0.00121 molar. Okay, so if you're using scientific notation, this will be 1.21 times 10 to the negative 3 molar. So that's my concentration. And then once you see this concentration, you go, that makes sense, right? That's quite low concentration. Again, remember when I talk about UV, the limitations, you cannot have a too high concentration because, right, you're supposed to keep your absorbance between 0.3 to 1. So again, when you get a concentration like this, you go, that makes sense. If you see a option having very high concentration, for usually the calculation is very high concentration, you go, that doesn't make sense. I know about my UV, I know math. You're gonna plug this Y right into equation 3, or you can plug into equation 1, depends on wherever you want. Okay, so I'm going to, since you already calculate one of the unknowns, so now you can plug in back into one of the equation to calculate it. I'm going to plug into equation 3 because that's nice and easy. I can just calculate the concentration of X. I already have the expression, so that's 0.722 times 212. Y's concentration I just calculated, so that's 1.21 times 10 to the power negative 3. So finish this calculation, the concentration of X turns out to be 6.47 times 10 to the negative 4 molar. Okay, so now that'll be the concentration of X in this mixture, and we also calculate concentration of Y in the mixture, then you're done. Okay, so then that's the whole calculation process. Okay, so like I said, the setup in the sense of chemistry wise is not bad at all, and then the rest is math, right? So if you're able to calculate this quickly and correctly during the exam. Okay, so then that's it. Okay, so this is a question you're solving, right? When you use UV measuring, getting the information absorbance at certain wavelength, when you have a mixture, you are able to figure out what's the concentration for each component in that mixture. Okay, so then that's all.